In this video, we're going to talk about why we need RabbitMQ in modern applications. And then we'll jump into how to use it with .NET 9. When you start building distributed systems or microservices, you quickly realize that direct communication between services using HTTP or gRPC can create tight coupling. Every time one service depends on another being online, your system becomes fragile. That's where RabbitMQ, a powerful message broker, comes in. A message broker is a middle layer that handles communication between different parts of your system. Instead of sending requests directly between services, you send messages to a queue, and the broker ensures they're delivered safely, asynchronously, and in order. It decouples your systems, improves scalability, and makes it easier to handle spikes in traffic without crashing your app. Think of it as a post office for your software. Producers drop off messages and consumers pick them up when ready. RabbitMQ is one of the most reliable and battle-tested brokers out there. It supports multiple messaging patterns: publish, subscribe, work queues, routing, topics, and more. It ensures that even if one service goes down, messages are never lost. They stay in the queue until the consumer is ready. Plus, with .NET 9's improved background services, worker services, and async capabilities, RabbitMQ integrates perfectly for building resilient microservices. Let's say you're building an e-commerce platform. When a customer places an order, the Order API shouldn't wait for the email service or the inventory service to finish their work. Instead, the Order API publishes an order-created message to RabbitMQ. The email service listens to that queue and sends a confirmation email. The inventory service listens to another queue and updates the stock. This way, each service is independent, scalable, and failure in one service won't block the others. Now that you understand why RabbitMQ is important and how message brokers fit into a .NET architecture, let's jump into the code and set up RabbitMQ with a .NET 9 worker service. We'll create a producer, a consumer, and test them end-to-end. Before we get started with coding, we need to set up our environment. For this demo, we'll be running RabbitMQ inside Docker, and instead of Docker Desktop, we'll use Rancher Desktop, which is a lightweight open-source alternative that works perfectly with Kubernetes and containerized services. So the first step is to download and install Rancher Desktop. You can go to rancherdesktop.io and download it for your operating system, Windows, macOS, or Linux. Once it's installed, make sure Containerd is selected as your container runtime, or Docker if you prefer, and start it up. Rancher will automatically create a local Kubernetes cluster, which we'll use later to deploy RabbitMQ. But for now, we'll just use it to run our RabbitMQ container locally. Once Rancher Desktop is up and running, open a terminal and let's pull the RabbitMQ Docker image. We'll run it locally so our producer and consumer can connect to it easily. Now that Rancher Desktop is ready, let's run RabbitMQ locally using a Docker container. Open your terminal and type the following command. This command starts RabbitMQ in the background with the management dashboard enabled. Port 5672 is used by your applications to send and receive messages, and port 15672 gives you access to the RabbitMQ management UI in your browser. Once it's running, open your browser and go to localhost. The default username and password are both guessed. You'll see the RabbitMQ dashboard, where you can monitor your queues, exchanges, and consumers in real time. Before jumping into .NET code, let's understand what we're about to build. We'll create two small .NET 9 applications. A producer that sends messages to RabbitMQ consumer that listens for those messages and processes them. The producer will represent something like an order service, and the consumer could be our email or notification service. This way, we'll see how RabbitMQ helps us decouple services and make communication asynchronous. All right, now that RabbitMQ is running, let's switch over to Visual Studio or Visual Studio Code. We'll start by creating a new project. Select Console App, choose .NET 9, and for the project name, type RabbitSender. For the solution name, let's call it RabbitMQ Project. This will help us group both the producer and consumer apps under the same solution later. Then click Create. Once the project is ready, open the Terminal or Package Manager console inside Visual Studio, and we'll add the RabbitMQ client library that lets us communicate with the message broker. In your terminal, type the following command: .NET add package RabbitMQ client. This package gives us everything we need to connect to RabbitMQ, declare queues, and publish messages. Inside the program file, let's start by importing the RabbitMQ namespace at the top, RabbitMQ client, and system text. Now, we'll set up a connection to RabbitMQ. Create a new connection factory and point it to our local server. Factory equal new connection factory. This factory will help us create a connection to our RabbitMQ broker running in Rancher desktop. This factory will help us create a connection to our RabbitMQ broker running in Rancher desktop. Next, we open a connection and a channel. Connection equal to factory, create connection, and a channel equal to connection, create model. Inside this channel, we'll declare a queue. If it doesn't exist, RabbitMQ will automatically create it. This queue will be where we send our messages. Now, let's send our first message. We'll create a simple string and convert it to a byte array before publishing it. This sends a message directly to our demo queue using the default exchange. Let's run the app. You should see Sent, Hello from Rabbit Sender in the console. Now head over to your browser again and go to the Queues tab. You'll see our demo queue and one ready message inside. That's the one we just published from .NET 9. So the producer side is working perfectly. Now let's create our second console application. This one will act as the message receiver or consumer. In Visual Studio, right-click on your solution RabbitMQ project, choose Add New Project and select Console App. We'll name this project Rabbit Receiver and keep it inside the same solution. Once it's created, just like before, add the RabbitMQ Nugget package. Inside the program file, start by importing the namespaces. Then, create a connection and open a channel just like we did in the sender. We'll declare the same queue, Hello Rabbit Demo, so that the receiver knows where to listen. Next, we create an event-based consumer that reacts whenever a new message arrives. Now it's time to test both apps together. First, run Rabbit Receiver. It will start waiting for messages. Then, run Rabbit Sender again. It will send the message to RabbitMQ. You should instantly see the receiver print. Received. Hello from Rabbit Sender. Congratulations! You've just built a working message producer and consumer with RabbitMQ and .NET 9.